Hello, we are discussing about GATE 2012 ECE paper. Look at the diagram where both the capacitors C1 and C2 are ideal. C1 has been charged to 12 volts before switch is closed at t is equal to 0. Find the type of current waveform. So, already capacitor C1 has been charged to 12 volts before switch is closed at t is equal to 0. So I am going for the first case for t less than 0 minus, that is switch is open and voltage across capacitor C1, okay, for this time, that is for time less than 0 minus, is already 12 volts. Okay, now it will be looks like the circuit diagram is switch is open and we are going with a capacitor C1 and it is connected to capacitor C2, but this is having a voltage of 12 volts. Since it is open circuit, no current flows into this side, so that I of t is equal to 0. So during this time, for time less than 0 minus, I of t is equal to 0 because of open circuit as the switch is open. Now what happens at t is equal to 0 plus, okay, so at t is equal to 0 plus, switch is closed. When switch is closed, it makes a closed loop. So the circuit is going to be looks like in this way, plus minus 12 volts, and this is C1, it is C2. Okay, we are interested in the current flowing through this C2, that is I of t waveform. Now I of t flows. Now I of t flows. So I at 0 plus flows because it makes a short circuit, it makes a closed loop. Okay, so how much current flows? Generally, whenever a switch is closed, by the time a closed loop forms, when the closed loop forms, current starts flowing. As the current starts flowing into capacitor, capacitor gets charged. Okay, and capacitor gets charged, C2 gets charged as current flows into it, any capacitor, if current starts flowing into it, then it starts charging. Okay, and how much it is going to be charges, it is based on time constant. So capacitor gets charged based on time constant. Time constant is indicated with tau and it is a product of R and C. Units are going to be seconds. So time constant indicates one time constant. Within one time constant, capacitor charges 63.2% of its final value. Within one time constant, capacitor charges 63.2% of its final value. And to reach the final value, for a capacitor to reach the final value, it requires minimum of 5 time constants. Now we will see what is the time constant of it, R and C. Okay, so this is R equivalent and C equivalent. C equivalent means C1 parallel C2 because both the capacitors should be considered as the current is flowing through both capacitors. Okay, so and R equivalent is 0 because this circuit doesn't contain any resistance. So 0 into C equivalent. So tau is equal to 0. That is 0 seconds. Within no time, that is within no time, capacitor C2 gets charged to the final value. So within 0 time, capacitor charges to the final value. That means voltage across capacitor C2 at t is equal to 0 plus itself, it reaches at 12 volts. Whenever capacitor reaches final value, it will be in the steady state. Okay, and when it is in steady state, it acts as open circuit because it has reached the final value. Okay, so this also will become 12 volts, this also will become 12 volts. So 12 volts and 12 volts, now current is not flowing because both the nodes are at the same voltage. So no current flows. I of t will become 0. So for t greater than 0 plus, okay, Vc1 is equal to Vc2, which is nothing but 12 volts, so that both nodes are going to be at same place and both the capacitors are going to be acting as open circuits. Both the capacitors are acting as open circuit C1 and C2 because they reach the steady state, and current flowing through it is going to be I of t is equal to 0. So from this one, if you want to plot the graph, so now I am plotting the graph. This is time scale and this is I of t. This is 0 minus and it is 0 plus. It is for t less than 0. This is for t greater than 0 plus. Okay. Now I is equal to 0. I is equal to 0 till 0 minus, and I is equal to 0 for t greater than 0 plus. T greater than 0 plus, but current flows only at t is equal to 0 plus. That means it looks like impulse. Current only flows at t is equal to 0, and current is 0 for t less than 0 minus and for t greater than 0 plus. So the waveform of the current is looks like impulse. So the right option for this question is D. The other way also we can say. Okay, so second method you can think it is. This is very easy. Second method, we know the relation between current and voltage of a capacitor. Okay, I is equal to C into dV by dt. So let us assume what is the type of voltage you are applying for a C2. Okay, for C2 the voltage applied is a step waveform, because for C2 voltage across C2, okay, for C2 till t is equal to 0 switch is open. That means no voltage is applied for the capacitor C2. That means 0. So this is 0. Voltage is 0 till 0 minus, and at t is equal to 0 plus, and afterwards voltage applied is 12 volts. So 12 volts voltage is continuously applying. So this is looks like 12 volts step. So voltage across C2 is 12 into U of t. It looks like. Okay. Now if you are going to consider current flowing through it, C into d by dt of 12 volts step, 12 into U of t, which means I is equal to 12 into C into d by dt of unit step function. Unit step function differentiation is impulse. 12C into impulse, that is nothing but delta of t. So this is the area under that delta of t. Strength of delta of t, or the area, this is the value which is area under the delta of t. So I is equal to delta of t, which is nothing but impulse function. So the right answer for this question is D itself.